Welcome to Lesson 4. We have queries. Queries you run by hand are not a project. They are a habit. In this lesson, we turn them into a job that runs at 7 every morning, whether you are awake or not, and we make it fail properly. Open run metrics.py. The whole file does 3 things in a fixed order. Load, measure, report. Load copies the raw table into the typed one. Measure runs the 3 queries. Report writes the numbers down. That is it. Here is the load. First, we delete everything in the orders table. Then, we run the insert. A full refresh every morning rather than working out which rows are new. On a table this size, that is simpler. And simple is what survives being unattended for 6 months. Now look closely at the insert statement itself. Back in queries.sql, because there is one thing missing from it deliberately. The amount column is not wrapped in cast. And you might think wrapping it would be safer. It is the exact opposite. Cast of n/a as real does not raise an error in SQLite. It returns 0.0. So adding cast would take a broken row, silently turn it into a 0, put that 0 into your revenue total, and let the job finish green. Leaving cast out is what lets the strict table do its job. Then the 3 metrics run in a loop, and the results go into a dictionary keyed by the query name. And now, the important half of this file, the except block. We catch SQLite error, which is the parent class of every database failure. So this one line catches a type rejection, a syntax mistake, and a locked file all the same way. Anything that is not a database error is a bug in this file, and a bug should crash loudly rather than get filed as a data problem. And here is what we do when it breaks, which is the design decision I most want you to steal. We do not try to fix anything. We write down exactly what we were doing when it broke into a file called lastfailure.json. The step name, the SQL we were running, the error type, and the error message. Then we exit with code 1. That is called a handoff. And look at what is not in that file. There is no guess at the cause, and there is nothing from your environment. Whatever picks this up gets the facts and nothing else. A job that tries to heal itself inline ends up swallowing errors. A job that writes a clean handoff can have anything on the other end of it. An agent, a Slack message, or a human at 9 in the morning. Right at the bottom, the agent gets called, and only under 2 conditions. Only if the job actually failed, and only if you passed the agent flag. A scheduled job that calls a paid model on every successful run is a bill for nothing. Now the scheduling itself, which is 4 lines and a lot of small print. On Mac or Linux, you type cron-tab-e and paste this. The 5 fields are minute, hour, day of month, and day of week. So 07*** means 7 in the morning, every day. And here are the 4 things people get wrong. In the order, they bite you. First, CD. Cron does not start in your project folder, so without that CD, Python cannot find the script, and the error looks like the file is missing when it is sitting right there. Second, the full path to Python. Cron gets an almost empty path, so the word Python on its own often is not found. Run which Python 3 and paste whatever it prints. Third, that redirect at the end. Cron mails its output to a mailbox nobody reads, so send it to a log file instead, and the 2 greater than 1 part is what captures errors, which is the whole reason this job exists. Fourth, the agent flag, or nothing investigates. On Windows, there is no cron. So there is a PowerShell script in the schedule folder that registers the same thing with Task Scheduler. One setting in there is worth knowing about. Start when available. A laptop that was asleep at 7 runs the job when it wakes up, instead of silently skipping the day. In Lesson 5, we build the thing on the other end of that handoff.